Hey everybody, this is Larry. This is me doing week 4 of the Leetcode weekly challenge. Yeah, right? Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's poem or this week's poem. Haven't done this one before, so new poem, yay. Today's poem is longest substring with at most 2 distinct characters. Okay, so given string S, we turn the length of the longest substring that contains 2 distinct characters. Alright, so this is a very standard application of course, sliding windows. The reason is because you have a substring, so you have a left side of the window, right side of the window, and then you're able to kind of choose greedy, right? And I think I've been thinking about how to kind of talk about sliding windows as well in the greedy part. The greedy part is very tough, but the idea here that I've been kind of playing around with these sliding windows is getting is actually rephrasing it a little bit. And what I mean by that is that instead of just having a window and be like, oh, this is a window, it's actually you're returning the best result. You're calculating the best result where the substring or the subarray rather ends in the right side of the window, right? So then now you're only adjusting left. The right will keep on walking, but you're only adjusting left in a greedy kind of way, because basically now the phrasing is you want to get the best answer where the right side, the subarray or substring ends on the right window, and then you have to adjust the left side to meet the criteria. And of course, there's a greedy. You have to do greedy proofs on top of that to kind of make sure that these things are optimal. But that's basically the idea, right? You have to prove optimality. So then now for right in range of n, right? So basically now we have let's just say a counter is equal to collection start counter. This is just a hash table, lookup table, but basically now we increment the counter, right? And then now while length of counter, which means the number of distinct characters, is more than 2, then now we have to remove it from the left side. So left is 0, and it is inclusive, right? So then now counter of s of left, we decrement, increment 1 because we just removed it, and then also we have to check that. I guess we should check this before we remove it. Or we move the thing. If this is equal to 0, then we delete it from the map. So then this counter will still be consistent, right? And then the longest is going to be best, right? So the best length. And basically, this is where loop invariant comes in. So after this loop invariant, after this loop, the invariant here on this part is going to be length of counter is going to be less than or equal to 2, which means that it has at most 2 distinct characters. So then now we have right is inclusive, left is inclusive. So then now we add 1 and best is equal to max of this. That should be pretty much it. Watch I make a silly mistake somewhere. But this is going to be linear time, constant space, constant because this will have at most 3 characters, right? And obviously everything else is linear, or everything else is constant, but you have a linear loop if you want to phrase it that way. That's all I have for this one. Let me know what you think. Let me know if I'm going too fast on these. But I would say sliding window is definitely something that you should practice a lot. If you're struggling with these are things that happen or often happens to show up on interviews. So definitely be prepared for it. Anyway, that's all I have for today. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.